Hey guys, here is a painting I made today with the kids. I thought it was impressive for my lack of artistic skill, and Lauren, I thought you'd appreciate. You know, there's some circles on there. You always seem to make fun of my circle drawing skills. So there you go. Multi-talented, guys. Multi-talented. So today what we're gonna do, or right now what we're gonna do, is we're gonna go over page 4 of your Regents packet that I sent home for you. Now notice we crossed off 3 of these examples. So I'm gonna go over number 1, and then I'm gonna teach you, it's not number 1, whatever, 8. And then I'm gonna teach you 9, 10, and 11. So it is what it is, right? We're just gonna go with it. So number 8 at the top of the page, what are the zeros of this function? Now you can cheat it. You can type this in a graph. And, well, you can't really cheat it that much. You can take a look in the graph. Remember, the zeros are where it hits the x-axis. But if you really want to find the zeros, what we're going to do is we're going to take all of these and we're going to factor them. So m squared minus 4 would be difference of squares, m plus 2 and m minus 2, which would give me roots at -2 and 2. Okay, -2 and 2. So we have another factor here. Now we know it's a degree 4. We got an m squared and an m squared. That's going to be a degree 4. So I know there's going to be 4 roots. 2 of them are rational. Here's the deal, guys. M squared plus 1 kind of fits difference of squares, but it doesn't because of this plus sign right here. So I taught you how to factor using imaginary numbers. All right, you do the same thing as difference of squares. So m squared is m times m, and 1 is 1 times 1. But because of that plus sign right there, we're going to go into imaginary world. So it's going to be 1i and 1i. That's how we do the difference of squares with a plus sign in the middle. We got to go into imaginary. Same thing, 1 is positive and 1 is negative. So we are also going to have imaginary roots at -i and positive I. So again, it was a degree 4 polynomial, and I do have 4 roots. So the answer is going to be number 4. Okay, you can half graph it. You're going to see these 2 roots. These ones you will not see, so you can't totally get around this one in a calculator, okay? So that's the one that you should know how to do. These ones we don't really know how to do. We're starting to get into logarithmic equations when we got dismissed from school. So in this one, we have a new car depreciating over time, and this is the car in June of 2011. The value of the car after t years is modeled by this equation. So we want to calculate the average decreasing rate of change per year from 2012 to 2014. So the first thing we're going to have to do is we're going to have to determine from June of 2011, how long is it, how much time has passed to get to June 2012? Well, that's pretty easy. Time has been 1 year for that portion. And we're going to do the same thing from June 2011 to June 2014. That has been 3 years. So that's your first step, is figuring out how many years we've had since the purchase of the car. Then we're going to take those t values and we're going to substitute them into that equation. So this is what it's going to look like. We've got log with a base of 0.8 v over 17,000 equals t, and this time I'm going to do 1. Now guys, we have the unique capability to use nsolve for this, but I am going to review with you how to do the switch equation. Remember, logarithm is just a fancy word for exponent. So the base of the logarithm is 0.8, so the base of my power is going to be 0.8. The exponent is 1. Boom, there's the exponent. And then it's going to equal this junk. Pretty sure that's not a mathematical term, but you know what I mean. Okay, so now I have an equation that I can solve. 0.8 to the first power is 0.8 equals that stuff again. And if I pop that over a 1, you can see that you're going to cross multiply. So 1 times v is v, and 0.8 times 17,000 is, what is it? 13,600. All right, so that's the value after 1 year. So we're gonna do the same exact thing, except we're gonna do it after 3 years. So here it is, still log base 0.8 of all of that stuff. But this time it's gonna equal 3 years. So same thing, the base of the exponent is 0.8. The exponent is 3. And it's gonna equal this stuff. Okay, 0.8 to the third power is what is it? 512, which equals all of that. Pop that over 1, cross multiply. We got V, the value of the car after 3 years, is 8,704. Welcome to your life, guys. The cars decrease in value quite a bit. So unfortunately, we've done all of this work so far, and now we have to figure out what the, the average decreasing rate of change. Now, we talked about rate of change a lot in Algebra 1. That's just calculating slope. So it went from this amount down to that amount. Oh, good Lord, that's me looking over my phone. Down to that amount. Okay, so how much did it decrease? Well, I would subtract those. It went down 4,896. Okay, it went down. Actually, I should probably make that negative. Well, it's saying decreasing. So it went down $4,896. And to calculate the slope, we're going to divide that by how long it took to do that. Well, from 1 to 3 years, that's 2 years, right? From 1 to 3, that's a 2-year span. So if you take 4,896 divided by 2, you get 2,448. That's your average rate of change. Average rate of change. Here's the problem. It's to the nearest $10. So 48 is closest to 50. All right, so that's your average rate of change using a logarithmic equation. That's kind of neat. Another one, actually, I probably should have left this one for you, but it's actually involving a formula that we haven't discussed yet. So I knocked it off, but you should be able to do it. This is the formula for a half-life. It doesn't matter what it's of or any of that. What we want to do is we want to take this formula and determine which one of these equations is equivalent to that. So if I take this, and remember, we always say, who does this exponent belong to? It only belongs to that guy. What I can do is I can separate this out. I can take the t and the 73.83 and I can write them as two different things. So 1 over 73.83, that I'm making that a fraction, times t. So if I evaluate little pieces of this, now remember, you got to follow your order of operations, okay? Parentheses, can't do anything there. Exponents come next, and this exponent only belongs to that 1/2. So if I evaluate this, and again, I can do it right in my calculator, and I'll show you. So we've got 1/2, let's bring up a fraction, 1/2, and we're going to raise that to the fraction 1 over 7383. That's what number that whole thing becomes. All right, so check it out. I didn't touch the 100 yet. All of this turned into 0.990656. And what didn't I do anything with yet? This exponent. So all I did is I followed my exponent rules and I came up with this answer. Oh my good Lord. Welcome to the crazy house, guys. Okay, this last one is a standard deviation question that you have no idea how to do yet. We don't cover until the end of the year. It is completely done in a calculator. So we've got a distribution of ball bearings. They're going to talk about, good Lord, I don't even know how to pause this video. It's going to talk about a normal distribution, okay? They're going to talk about an average. They're going to talk about a standard deviation. Okay, when they talk about all of these things, you're going to do the same thing every single time. We'll draw this little picture, okay? A normal distribution is a bell-shaped curve. It goes up and then it comes down, right? Most people are average. That's why the hump is in the middle. Some people are above average, some people are below average, and whatever you're talking about, okay? So the average is right here. Oops, av. And they told me that the average or the mean is 4 centimeters. So the average is 4 centimeters. The standard deviation is 0.2. We can write standard deviation in our calculator as SX or sometimes theta x. No, that's not theta. I don't know what Greek letter this is off the top of my head right now. So anyway, this is our standard deviation. That's besides the point. So the question is going to say, what proportion of the ball bearings will have a diameter less than 3.7? So 3.7 is below here, right? There's 3.7. And I want to know what proportion is less than that. So I want to find how many ball bearings are going to be in this section right here, okay? Again, once you have this, this is your work. If you have to do this on a part 2 question, this is what you want to show. Once you have this, you have to go into your calculator, okay? And there's a series of buttons you have to hit. And again, I haven't taught you this yet. It's menu, 5 for probability, 5 for distributions, 5, 5, 2, normal CDF. Now this is, again, super new. First question is lower bound. So if you look at my graph, there is no ending to this. It's going to go on forever, okay? There is no line saying stop here. So the lower bound is negative infinity, which means there is no lower bound, all right? Then I hit tab, upper bound. Well, do you see where I have stopped that coloring? I've literally stopped it. I've put a boundary right here at 3.7. So on my calculator, upper bound, I put 3.7. Tab. The next thing, this little funny symbol here is a fancy way of asking you for the average. Well, lucky for us, they're going to always tell me the average. In this case, the average is 4. And then this is your standard deviation. Again, standard deviation was given to you is 0.2. That's all you have to do. And then I'm just going to hit my enter button. And I got to hit it twice for some reason. And boom, it calculates the probability for you. So the chance that a ball bearing is going to be in this shaded area is, what is that? 0.066807. We can change that to a percent if we had to. We change it by moving it 2 places. So about 6.7% of the ball bearings are going to be in that shaded area. But I didn't have to. This is the answer. So if you look over here, number 1 is what matches with that. All right. Welcome to the Schneider Crazy House. And remember, don't worry. Be happy. Talk to you guys later.